Hello everybody, let's solve some more quadratic inequalities. Now if you haven't already, I encourage you to watch the previous video I did on this topic. These ones I'm going to go through in this video are just slightly more challenging. So as always, pause the video and see if you can have a go at doing these yourself first. Okay, let's go through this first one. So we've got 5x squared plus 7x plus 2 is less than 0. So with all quadratic inequalities, the first step I always do is to change the inequality to an equation and then solve that equation. So I'm just going to rewrite this inequality as an equation first. And now let's go ahead and solve this equation. Now there are a few ways we could solve it. We could use the quadratic formula, but I'm going to factorise because it does factorise quite nicely. So if we think about two numbers that multiply together to get 5 times 2, so multiply together to get 10 and add together to get this number. So add together to get 7. Well, if we think about it, 5 and 2 would work. 5 times 2 is 10 and 5 plus 2 is 7. So we can split this middle term up into 5x and 2x. So we'll be left with 5x squared plus 5x plus 2x plus 2 equals 0. Notice these two equations are exactly the same. I've just broken this 7x down into 5x and 2x. And now we can factorise. So if we focus on this bit in blue, we can factor out a 5x. And then in our brackets, we're just going to be left with x plus 1. And now if we focus on this part in fuchsia, well, we can factor out a 2. So if we factor out a positive 2, in our brackets, we're also left with x plus 1. So we have an x plus 1 here and an x plus 1 here. So we can factor out an x plus 1. So if we factor out an x plus 1, and then all we're left with is 5x plus 2. 5x plus 2. And obviously all of that equals 0. So we're going to have two solutions. Either x plus 1 is going to equal 0. So x plus 1 equals 0. Or our other solution is going to be when 5x plus 2 equals 0. So we just need to solve each of these linear equations. So for this case, x is going to equal -1. And for this case over here, well, first of all, let's subtract 2 from both sides. So we'd be left with 5x is equal to -2. And then if we divide both sides by 5, we get x is equal to -2/5. So now we have solved the equation, we can sketch the graph. So let's first of all plot our roots. So we have one at -1, let's say that that is about there. And the other one at -2/5. So let's say that that is there. And now we just need to draw our curve. And it's going to be a U-shaped curve because we've got a positive coefficient on our x squared term. So it's going to look something like this. There we go. And now we just need to identify the correct region. So if we go back to our original inequality, we're looking at all of the points on the graph that are less than 0. So let's draw the line in y equals 0 first. And because we're looking at less than 0, we will be looking underneath the line. So it's going to be all of this business here. So what x values do these correspond to? Well, it's going to be everything between -1 and -2/5, because it is all of this area here. So if we were to write this out as a inequality, we'd have -1 as our lower bound, we'd have -2/5 as our upper bound, and our value for x will be between these two. So it's going to be greater than -1, but less than -2/5. So this here is our solution. Okay, so I've got another question here. So pause the video again and see if you can solve this inequality, giving your answer using surds. Okay, so the first step, as always, is to change the inequality into an equation. And now we can solve this equation. And now because I know our answer is going to involve surds, it looks like we can't factorise this. So there's a few ways we could solve it. We could use the quadratic formula, but I'm going to complete the square. Now, if you're a bit unsure of how to complete the square, again, I encourage you to go back and watch one of my previous videos on this topic. I've actually got quite a few of them. So to complete the square, the first thing we do is just rewrite the expression. So x squared plus 6x. But instead of writing plus 3, I'm just going to leave a space and then write plus 3. Okay. And then obviously that equals 0. Now the reason I've left a space is so that we can complete the square. So to complete the square, we half this number and then we square it. So half of 6 is 3, 3 squared is 9, so we need to add on 9. Now, we can't just add on 9, we also have to subtract 9 because we need to make sure that the equation is the same. But now, after doing all of that, if we focus on this part, this does now factorise. This factorises to x plus 3 squared. And you can check that if you want by expanding this out. And then we've got plus 3 minus 9, which is just minus 6. And then that equals 0. So now we've got it into a form that we can solve. So if I just bring it over here, first thing we can do is just add 6 to both sides. So we'll be left with x plus 3, all of that squared, is equal to 6. And then if we take the square root of both sides, we'll be left with x plus 3 equals plus or minus the square root of 6. Don't forget your plus or minus. And then the last step is just to subtract 3 from both sides. So we'll be left with x is equal to plus or minus the square root of 6, take away 3. So we found our solution. Now we can sketch the graph. So let's plot our two roots first. So the first one is going to be negative root 6 minus 3. So let's say that that is over here. Negative root 6 minus 3. And then our other solution will be positive root 6 minus 3, which will be somewhere around here, because I know that square root of 6 is less than 3. So it's going to be slightly negative. So that's going to be root 6 minus 3. And now if we draw in the curve, it's going to be a U shape because it's a positive coefficient. So it's going to look something like this. And now let's take a look at our inequality. We have greater than 0. So we're looking at anything above the line y equals 0. So we'll be looking at all of these points here and all of these points over here. So what x values do these correspond to? Well, it's going to be everything to the left of this point and to the right of this point. So let's write down our inequality. It's going to be less than negative root 6 minus 3. Or our other solution is going to be greater than this point here. So that's just positive root 6 minus 3. So this is our solution. Okay, I've got one more question to have a go at, and this time it's a problem solving question. So let's go through this. The width of the rectangular field is x meters. So I always like to draw out diagrams to represent what's going on. So let's say that this is our rectangular field and the width is x. Okay. Now the second line says the length of the field is 30 meters longer than the width. So this is our length and it's 30 meters longer than the width. So it's going to be our width plus 30. And now the third line says the perimeter of the rectangular field is less than 500 meters. So let's first of all write down an expression for the perimeter. So we know that this is x and this is x plus 30. So the perimeter is going to be x, let's write this down here, x plus x plus 30 plus another x plus 30. And we know that the perimeter of the field is less than 500 meters. So that's going to be less than 500. Now we can tidy this up a bit. If we simplify, we've got x plus x plus x plus x. Well, that's going to be 4x. And then we've got plus 60. That is going to be less than 500. And now if we subtract 60 from both sides, we're going to be left with 4x is less than 440. Now we can divide both sides by 4. We get x is less than 110. So the width has to be less than 110 meters. And now let's look at the last line. It says the area of the field is greater than 4,000 meters squared. So first of all, let's write down an expression for the area. So we know the area is going to be the width times the length. So the area is going to be x times x plus 30. And we know that that has to be greater, so that is greater than 4,000. So let's first of all expand the brackets. So we're going to be left with x squared plus 30x is greater than 4,000. And now let's put it into a form we can solve. If we get 0 on this side, so if we subtract 4,000 from both sides, we get x squared plus 30x minus 4,000 is greater than 0. So now we have a nice quadratic inequality and we know how to solve these. So the first step is to change the inequality to an equation. So all I've done here is I've just replaced the greater than symbol with an equal symbol. And now we can solve this quadratic equation. Now I'm going to use the quadratic formula because I think it's being a bit left out. I haven't used it yet. So let's just remind ourselves of what the formula is. So the formula is x is equal to negative b plus or minus the square root of b squared minus 4ac. And then all of that is over 2a. So now we can just plug in our numbers. So we've got x is equal to negative b, or b is 30, so it's going to be negative 30 plus or minus the square root of b squared, so 30 squared, minus 4 times a, or a is just 1, times c, c is negative 4,000. Negative 4,000. And then again, all of that is going to be over 2a, or a is just 1, so it's just 2 times 1, which is 2. So just to save a bit of time, I'm going to plug all of this into my calculator. And when I do that, one of my solutions is x is equal to 50. And it's always nice when you get a number like this. It means that you've probably got the right answer. Or, remember, there are two solutions because of the plus and minus. The other solution is x is equal to negative 80. So now we have our solutions, we can sketch the graph. So let's first of all plug our roots in. So we've got one which is 50. And then the other root is negative 80. And then the curve is going to be a U shape because we've got a positive coefficient here. So it's going to look something like that. And now let's take a look back at our original inequality over here. And we are looking for all the values that are greater than the line y equals 0. So we're going to be looking at these values here and these values here. So what do they correspond to? Well, in this direction, these are all of the things less than negative 80. So we're going to have x is less than negative 80. And all of these values over here will be greater than 50. So x is going to be greater than 50. Now, those of you who are on the ball may have noticed something, and that is that this solution here does not make sense. It is not valid. And the reason it's not valid is because you cannot have a length less than negative 80 meters. Okay, you can't have a negative length anyway. So this answer just doesn't make any sense whatsoever. Okay, so our only valid solutions are this one here. So our width has to be greater than 50 meters, and our width also has to be less than 110 meters. Now, when I was over here, I could have stopped and said that this answer isn't valid, but I wanted to include both roots just so it helped me draw the quadratic graph. So what is our final solution? Well, our width has to be greater than 50 meters. So 50 meters is our lower bound. So it's greater than 50 meters, but less than 110 meters. So this here is our final solution. So how did you get on with those 3 questions? Now, if you didn't get them all correct, don't worry too much because this is quite a tricky topic. It's about a grade 8/9 in your maths GCSEs. But hopefully, at least, this video helped you with your understanding of this topic. So thank you for watching, and hopefully I'll see you in the next video. Take care.